Uh, okay, good evening, everyone. We'll be starting shortly. I think it's almost 8:30, so we'll be starting shortly. I welcome each and every one of us. Please let me see a thumbs up if you can hear me. Uh, okay, so it's 8:30. Let's just give let's say in the next 3 minutes, 3 minutes, and would would start. Okay, for those of us that are just joining, we'll be starting in the next 2 minutes. That's eight at exactly 8:33. Okay, okay, we can start. So, good evening, everyone. I welcome you all to this edition of our lightning session. Please give a thumbs up if you can hear me, or just react if you can hear my voice. Okay, okay. Thank you very much. Thank you very much. Okay, so today's session um we'll be having a very good friend of mine and very good friend of mine and a senior developer. He will be taking us on a very important topic, very very important. He will be taking us on transactional management in Spring Boot and is understanding the concept of transactional management in Spring Boot. And It's something that's very important, because there are many things that Spring Boot has handled for us underneath that we really do not grasp, because when it comes to, let's say, dealing with some core, or when you have to make some critical adjustments, that's where you see those things in play. So you'll be taking us on a very important topic, and let's have our pen, our paper, and be ready to learn. So, Mr. Sampson, you have the floor.
Hello, everyone. Good evening. Good evening to you all. And thank you, Mr. Samuel. Uh, just a little correction in it. We're still growing, even though we use the word senior developer a lot of times. Please confirm you can hear me clearly. All right.
Yes, we
All
can
right.
hear you.
All right. Thank you. I'm not a senior developer yet, but by God's grace, we're still making progress and we're still growing. I want to especially thank the organizers of this meeting for having me. And I want to also thank you all for joining. So, what we'll be looking at today is a very important topic, like our moderator has already said. And it's for us developers, particularly in the Spring framework and also Spring Boot, we use some of these annotations or these annotations a lot of times, and sometimes we just see it like it's not important, but this is why we're here today, to really see how and why and what it is doing without some of our knowledge. Like at the very first time I used this annotation, I didn't know what was happening. I was just told to use it, like this would help you. But it worked like magic in some sense, because there was some logs at a point in time, and I could see what the logs were saying. And but then when something now happened, I now found out that the thing I was trying to commit, like the method I was trying to complete, did not really take effect in the database, and I was surprised. On the log, it was saying this, but on the database is absolutely empty, because nothing, those changes that I was expecting did not happen because of some errors that was thrown. So I was hoping to go and delete some of the things that are not needed because they did not run completely. But eventually, I got to understand that this is why the annotation is needed. And our topic today, like I said, is understanding transactional management in Spring Boot. But we can't talk about transactional management in Spring Boot without even looking at where it came from, because this annotation had actually evolved from the time where there were no annotations for it, where the traditional methods of rolling back features were being done, to when we now have an annotation for it that gave us more options to either use a declarative process or a programmatic process. Please, can you confirm my slide is up, please?
No, no, we can't see your slide. Oh, I don't know. Is that for me?
Can you help me share?
Okay,
I
okay.
believe you should
Let me
have
do that.
access. Can you help me share? Because apologies, my network, I don't know if it's because of the rain. It's
Okay, so confirm you can see my screen.
Yes, I can see that.
Okay, so
All right. So, and part of what we aim to achieve here today is to understand or master the act of managing database transactions with Spring Boot applications. And if we are moving on to the next slide, you then ask yourself, what is this transaction that we're actually talking about? You can go to the next slide, please. What is this transaction that we're talking about? Why the need for transaction? And transaction itself is a unit of work that must be completed all at once or not at all. Like a very popular phrase says all or nothing, all or nothing. That's one of the first things I heard when I started learning about transaction annotations or transaction management itself. They say what it does is that it allows everything to work, or it does not even allow anything to work at all. And one of the importance of this annotation is that it ensures data integrity in operations, in critical operations. It also maintains consistency. Just like I said, all or nothing is guaranteed, And how this thing, if you look at the very first example, which is the bank transfer, can you give us the full screen, the full slide? Maybe just go
Oh,
to slideshow so they can see it, because some things are tiny a bit. It's just above there. All right, very good. Thank you. Okay, so if you look at the very first example, you would find out that without it, a lot of things can go wrong, where you would have some issues with your database, or probably network errors at some point in time, and some things may just be lost in transit. So imagine you're building a banking application, or your bank, for instance, and you try to credit or debit money for a certain purpose to be able to credit somewhere else. And at a point in time when you're doing that, your your network actually fluctuated, probably network cut off, or there's a disconnection between the database seeing your funds, or even moving the funds from your profile or your account to another. And at that point in time, you get debited. And the money that was supposed to credit the destination did not actually go through. You understand? And when you inquire, you found out that the money is missing. There's no trace of it. They can't find it. You'd probably question who did this, because this is one of the things transaction helps us to do. At that point in time, whether there's a disconnection, whether it is coming from probably power or network issues, you'd find out that there is a rollback automatically. And that is one important feature of transaction. And if you'd see the solution, it's like there's a start from the banking perspective. It starts the transaction, it probably debits the source, which is the first thing to happen, and then it credits the destination, and then it commits the transaction. This is just like the four processes of a full banking transaction. When you're performing a transaction with your bank account, these are four processes. It debits, it credits, and it commits to the database. And if all these four things happens correctly, your transaction is successful. If there is any point in time where each one of these processes fails, then you find out that you either get a reversal, like we usually do, or you probably lost your money. But I doubt that is happening to any of us, because I know we would storm that bank today and explode everywhere. So one thing, one of the ways we guarantee, or one of the ways transaction annotation is guaranteed, is through the measure of ACID properties. And by ACID properties, you're not talking about chemistry, but we're actually talking about some acronyms in database management or database itself. So what ACID properties helps us to do is that it's a way for us to measure it's a reliable way of transaction, of which transaction is against the ACID property. So we use ACID property to measure transactions. It's a principle that we use to also validate a lot of things, despite power issues, despite errors in our code, despite anything. So this is the way for us to say that yes, our transaction is actually working perfectly. And the first one of the acronyms is atomicity. We have consistency, we have isolation, and we also have the very last one, which is durability. So these four properties are used to measure transaction. And when we talk about atomicity, we're referring to the all or nothing proverbs, if I would say, or use of words, if I would say. So what it does is that it ensures that all operations that we are carrying out is either successful or they are not successful at all. So in the case of anything within the process of performing a complete operation, if there is anything that should stop that flow, our transactions are rolled back to the state it was before that operation was carried out. I hope we're actually following, please. So that is actually what it allows us to do. Then if you look at the next part, when we talk about consistency, it allows us to maintain valid data before and after an operation is carried out. So take, for instance, that our database is, let's say, probably a date time type or a string type, for instance. And then all of a sudden within your transaction, you want to commit a number onto that particular database that is actually a string. You understand? So what you're going to get in your application when you probably run it, you get maybe if it's an SQL, you get an SQL error, but you surely get a database error. You understand? Because why? The database itself, it's giving us, or it's enforcing consistency to our values. So if you're putting a string, if the database is annotated to receive a string or to store a string on a particular column, that is what it is collecting. And take, for instance, for our banking transaction, again, which is one of the things I would use as our main example. For our banking transaction, if our database has been mapped or programmed to not receive a negative value, for every time where the negative values are being or trying to be sent to that database, you'd either get it enforced or restricted to becoming zero automatically than for it to change to a negative value. So this is what consistency of the ACID property allows us to do. It enforces that our database remains the same way it has been scheduled, it has been designed to be before and after an operation. You understand? So the next one is isolation. So what isolation allows us to do is that it does not conflict two transactions together. So it means that in the advent of concurrent transaction running, no two transactions interfere with each other. That's just what it means. So it tells the data, it tells our application that one thing should happen before the other. Even though we're doing concurrency, even though we're trying to perform concurrency at this point in time, they do not interfere. They do not interfere to each other. They can work together, but they do not interfere. That's what isolation, that each entity, each method is, or each, what's the word I'm going to use right now? Each process is actually independent. However, they can work together. That's what it means. So they don't have to break into each other to be able to continue themselves. So you can see our example here. And part of the things that this helps us to do is to prevent dirty reads. You understand? Is to prevent dirty read. And if you can remember, a dirty read in our database is when a transaction has when a data has been modified by another but not committed. So in an event where um, a particular method had altered the database and it has not committed it, one transaction waits for it to be committed before it continues, so that you don't have inconsistencies with your data, with how your data are being, or how your data is being seen by your application. The next one we're going to be looking at is durability, and which is, in simple terms, once a data has been committed onto the database, it remains. That's just what it means. whether that data, whether there is a power outage or anything, once you bring it back on, the data that has been committed remains the same way it has been. No changes to it, except you change those data by yourself. And for you to also see the changes, you need to commit it again as well. So that is what it means. Like from what I have here, it says once a transaction has been committed, its changes are permanent and will survive any subsequent system failures. So those changes, as long as it has been committed onto the database, it remains there permanently. And we would go back to the evolution of Spring of transaction. Like I don't know if we can really see this. I don't know if we can really see this. Maybe I can get a response if we can see this. All right, thank you very much. So from the traditional approach, you would find out that some things were done to be able to manage this transaction process without an annotation. From then, when the idea of let's try to roll back, or let's try to come back to how a state, how our application was before we performed that particular operation, you would see that there were things done manually. So one of the benefits of this particular approach was that it gave control. So you had control to do how you like as a developer. But it also came with a problem, which was that it was verbose and it increased the amount of codes you would write. You know, Java, they say it's currently a robust language. You can, one small thing you would want to do, you would write too many lines of code, unlike other brothers, Python and the rest of them. You understand? So it made things easy in the sense that you are in control, but it made things hard in the sense that you would have to do a lot of work. So it was, I would say, time consuming, because for you to get these things done, you're spending more time. So if you check, there's a connection that you would need to get from the database. You then set the connection to either commit, to either, okay, you either set the connection to either auto commit or you not. Then you finally roll back in an event of probably an error. And imagine you're doing this for, let's say, two different methods that are doing two different things. Let's say one of them has to do with an account and the other has to do with probably someone onboarding on your application and the name. You understand? So for you not to have issues with how their onboarding processes work, this is not even the funds in their accounts. For you not to have issues with how their onboarding processes work, whereby if they have an issue at the point of committing that particular application, it rolls them back and probably starts them again all over from the beginning, instead of committing part registration on your database. And when your user comes in, you find out that I did not submit my form completely. I had some issues. I did not know what happened, but then it's telling me that I am already registered, but however, I cannot log in because I did not set my password. You understand? So things like that happen. And we are still a growing country, so our network sometimes it behaves funny too. So because of some of these things, you would end up seeing too many lines of code, because you're writing one for the account or the wallet processes, you're writing another script, or if I would say another lines of code for rollback of registration process. So it became so much, but then that's where Spring actually came in with a declarative approach, where you can actually use the annotation to help yourself. But however, there are two types of transactional approach: the programmatic and the declarative. And on the left side, which is what I tagged the the traditional approach, that is the programmatic approach of managing transactions. And on the right side, which is Spring declarative approach, that's the declarative way of managing transactions. Which one of the benefits of this is that it is clean it is concise, but however, it takes out a lot of things from us. So some of the processes that we would manage with the traditional approach, some of those processes have already been managed for us or have already been done sort of for us. So it's like it has reduced some of our workload and then gave us something simpler. I hope I hope we're following. So if there's any question, you can also just pen it down, and we'll look at it by the end of our discussion. And now we moved out of how Spring tells us to do some of these things, because Spring gave us some instances, but then we would want to look at the magic of transactional in Spring Boot per se. So how it functions in Spring Boot, because how it functions in Spring, you have more control to do a lot of things. And Spring Boot now made it much more easier for developers, because now they have actually still abstracted a lot of things from the way it was done in Spring, and then Spring Boot now made it much more easier. So by just calling a thing or two, it is functioning in a certain way, which we'll get into very soon. So like I said earlier on, the transactional annotation is a cornerstone of Spring declarative transactional management process. And then don't forget, we have two processes, which is the programmatic and the declarative that is coming from Spring. But then the Spring Boot actually focused on one mainly, which is the declarative. And transaction defines boundaries directly on methods or classes. So abstracting a lot of things away from us, that's one of the things it also did for us too. So if you look at the before at transactional on the left side of the screen, you would also see the same things, where you would have to be the one to get the connection, you'd have to be the one to set the auto commit, and you'd have to be the one to close that connection at that particular point in time. So after you've done your main business logic, you still need to handle transactions. If it doesn't go the way you intended to, then perform this other action. So that's just it. But with the declarative method, which Spring Boot provided for us, you then just need to use an annotation, and that annotation performs all of these lines of code. So you can see a very big difference here between the left part of our screen and then the right part of our screen. So you'd see that just one line is doing what 5 to 6 line was doing previously, and this is like a very big upgrade. But underneath the hood, there are lots of things happening, which we would still talk about a little bit. All right, so we would move on to understanding transaction propagation. So while Spring Boot took away some things, it also created a way for us to be able to somewhat manage these things by ourselves. And then that is where it provided us with two major things, which is isolation and propagation. You understand? So we would go down to isolation, but first we want to talk about propagation. So it brought about two things: isolation and propagation. Please, let's hold on to that first. So we'll be looking at isolation from the first instance. I'm sorry, propagation from the very first instance. Propagation dictates how transaction boundaries behave when one transaction method is called inside another. And I'll give you a very quick example. Let's say you have a main method, like not a main method per se, you have let's say a method inside a service class, and you have another method somewhere in another service class, but you want to use the other method inside this let's say user account service or user service, and let's say wallet service. You have a method in user service and you have another method in wallet service. and you want to use the method in wallet service inside user service. And both methods have transaction annotation. What it is saying is that with the propagation approach, you can then tell Spring how to behave in that particular way, in that particular instance, because ordinarily a transaction should function for a method. But now you're using two transactions to function in two different methods for a particular process. I hope I'm not sounding confusing. Please, if there's any need for you to call my attention, please, you can just let me know. So you're using two transactional annotation in two methods to perform a particular process. You understand? So one method is being called inside another method, but then the two methods individually has transactional annotation. What it is saying here is that propagation tells us how to handle transactions in that instance. And from what we have here, there are two main ways we can do that. Two main ways, but it is not only two. There are about 5 of them in total. And I will name all 5 of them. So we have the required, which is the default state that a transaction should be, a propagation should be. We have the requires new. Then we also have the mandatory, we have the supports, and we have never. All these are different types of propagation. All these are different types of propagation that can be used. But in a lot of times, we're only using two. In a lot of times, we're only using two, but it is more than two. It is about 5 of them. So the mandatory, what it does is that it is a must-have. So it is compulsory that you would have a transaction in the main class. You understand? So even if the subclass does not have, even if the other class that you're calling inside the main one does not have, it would still work. That is what the mandatory is. And it is still in a way pointing towards the required. So that is why a lot of times we don't get to know about those particular methods in propagation, because they are somewhat pointing towards these two. If you look at what the support means, the support is almost talking to what the requires new means in a way, only that the support, if you put transactional annotation in the second method or you don't put it, it does not mind. That's what support means. That's what the support means. So it does not care whether there is a transactional annotation on the second method, but if you have it, it is fine. If you do not have it, it is fine. And then the never method, you don't even need it. That's the never method. You don't even need it. So focusing on our two main types of propagation, or two main methods inside propagation, which is the required and the requires new. So what the requires does is that it joins the second method into the first method. It joins it into it. So what we would have, if in the first method there is a problem, it means that the second method would also roll back. That's what it means. So it just joins the two of them, just joins them inside. So if you look at what we have, it says that it creates a new, it joins existing transaction if one exists. It creates a new one if none exists. You understand? And most common or most often desired. So those are the two things that it does. So it joins one transactional method into another when there are two existing methods. But if there is none existing, it creates another one for himself. You understand? And we would look at, if you look at the requires new is a little bit different from what the required does. What it means is that at every point in time, whether the first one has transactional annotation used there, it would still create its own. That is what it will do. It will still create its own. It would always be independent of the first one. So the first one should just be on its own. me, I will be on my own, but I will still do my own check. It just depends on your business logic. There's a question here that I just had. So which should you use if you'd want to ask the question? Should I use a new transaction, or should I join with an existing one? Absolutely, you can do either ways. It depends on your business logic. It depends on how you intend to handle things, or it depends on what you're working on. So if what you're working on requires you to join an existing transactional annotation to be able to function properly, fine. If what you're working on needs everything to be independent of each other, while you do your own, I do my own, we're all trying to achieve the same aim, it's still fine. You understand? So the so if you look at the required example, what it is saying, this is how you can use it. You just inside the transactional annotation, you put a bracket, you put propagation, and you call the propagation dot required, or you also call the propagation dot requires new. In your Java Spring Boot application, this is available for use. All right. So so one last thing is that we use propagation that requires new propagation for operation that must be committed or rolled back independently, just like as I've always said. So if you want your operation, or if you want your operation to be independent of the first one, you just have to use the requires new methods to be able to do that. And then we would move on to the isolation levels. So what isolation does on our application is that it ensures that transaction sees a consistent view of data even when the other transactions are running at the same time. So it isolates one from the other. So it's just at every point in time, it ensures that method B sees a consistent view of method A, even though they are running at the same time. That's what it means. So in an e-commerce application, take for instance, before you make a purchase or before you buy a product in an e-commerce application, you would notice that if the product is not in stock, you cannot even proceed. In some applications, you cannot proceed to make that purchase, or you cannot proceed to even place that order. Assuming that product exists, what it means is that it will go back to the inventory, debit the inventory, or take out the amount of products you're buying from that inventory. You understand? And then go to the payment process or the payment flow, generate a method or a way for you to make payments, come back to, it is still the same, it is still just one click. Come back, use that payment or checks for that payment if it has been received, use it to now push your order to probably somewhere or somebody. So if you check very well, it is just one particular flow, but it is doing a lot of things. So at that point in time, probably you've actually set up your pipeline to run. Let's say you've clicked on purchase product or purchase item, and then it checks that there's no product, or the product is remaining one. You may not be able to continue, or you may just be told to probably reduce your amount. So it means that at every point in time, each process is independent of the other, ensuring us to maintain data consistency and also performance. Are we together? And the isolation, what it does, it gives us four common isolation levels that we have. And then we have the read uncommitted, we have the read committed, we have the repeatable read, and we have the serializable. And from what we have here, you'd see that the lowest level of isolation is the read uncommitted. And one of the things that the read uncommitted helps us to prevent is that it prevents dirty read. Hello? Can you hear me? All right. So sorry about that. So one of the things that the read uncommitted helps us to prevent is that it prevents dirty read. It also helps us to not to repeat, it also helps to prevent non-repeatable reads. It also prevents phantom reads. So if we are talking about dirty reads, like I have said previously, it is when a database reads data that has been modified but by another application or by another service but has not been committed. The non-repeatable read, what it means is that it is when a transaction rereads the same row and finds that the data has been changed. So it is like doing one particular or checking one particular rule multiple times, and then it finds out that that rule, when I saw it before, it was like this, and now it is looking like something else. So it means that you would have, in a way, inconsistent data at some point in time, because if you're looking at 4 naira, for instance, and then at the point in time when you saw it, it was 4 naira, which was fine, and then the next time when you looked at it, you're seeing less than 4 naira, you would probably get inconsistent values on your application, or depending on how you set it, you may probably get an exception thrown at you. So the other thing it helps us to prevent is that it also prevents phantom read, which is when a transaction executes or re-execute as a query and gets different set of rows. So having multiple rows created. So this is like the lowest level of isolation. So this is like the lowest level of isolation. And then the read committed, it prevents dirty read. So the read uncommitted does not prevent this. So it does not prevent these particular three things I just mentioned, which is the dirty read, the non-repeatable read, and the phantom read. It does not prevent any of those. But however, the read committed prevents dirty read, but does not prevent repeatable read. It does not also prevent phantom read. You understand? Then the repeatable read, what it does is that it prevents dirty read, it prevents non-repeatable read, but does not prevent phantom read. Just like as I've mentioned. Then serializable, which is the highest level of isolation, prevents all three of them, both the dirty read, the non-repeatable read, the phantom read. It prevents all of them. So, and for myself, some of the applications I've worked with, if I remember very well, at the beginning of the class, when it's being created, we usually do something. We usually implement serializable. That's like a class on its own in Java. So that's itself. What serializable helps us to do is to allow Spring to also know that this particular application should run after another, or should be running in sequence. You understand? So moving on, we'll be looking at some of the common pitfalls or common issues to which we experience, or some of the reasons why sometimes when we see transactions, when we implement transactions, it's not really working the way we intend it or the way we want it to work. There are times where you must have annotated transaction, a method, but you would find out that it did not perform the way you want it to. You're expecting it to roll back at a certain point, but the rollback did not happen. And these are some of the common issues to which that, or why that particular function did not happen. You understand? So one of the problems is that it's a proxy problem. I forgot to mention at when we're starting, how Spring does this transaction annotation is by the use of AOPs in Spring Boot or in Spring framework. That is aspect-oriented programming. I know we mostly know about object-oriented programming, but there's also what we call aspect-oriented programming. So that is how Spring performs this. But before we conclude tonight, I am just briefly going to talk about that. So one of the very common problems we we have around this is a proxy problem. And the problem is that there's an internal method call bypassing Spring proxy mechanisms. Another problem is also transactional method call internally will not start a new transaction. You understand? And proxy is required for transaction annotation to work. So there's a little bit of code over there. So you can see from here that there's a proxy there's an internal call of a transactional annotation, but it was not even told what to do. So it is like you saying Spring should run two proxies at the same time without telling him how to run it. So you would find out that two of the annotations I'm talking to the left part of the example now, for instance, the two of the annotations are trying to run at the same time. So there's an internal call because you did not actually tell it how to run or how to function. So there's an internal call. And with this now, Spring is confused because the both of them wants to do the same thing at the same time. But the solution here is to use a self-injection method to get the proxy instance, called the transactional method through a proxy instance. So with that now, one would run at a point in time and the other would run after the first proxy has actually run. Alternatively is to extract the transactional logic to a separate beam. So you can also use a beam to actually do that when you're facing an internal call issue. So the next one we have here is the access modifier and exception handling problem. So one of the things is that Spring does not work on private methods. When a method is private, it only works on public methods. So that's the aspect-oriented programming mechanism does not work on private methods. So if you're annotating a private method with a transactional annotation, you will not get an error. You will not get an error, but it will not work. That's what it means. So some of the times we do not know. I think one of the first time I experienced this was that I was not aware, so you may not even know that this is a problem. You would only just ask yourself, but I have annotated this method with transactional. Why is it not working? So you would just need to change from it being a public method from it being a private method rather to it being a public method, and that's the way Spring would be able to function properly. And the second problem is an exception issue, which is by default, Spring only triggers rollback for unchecked exceptions. So once you check your exception, you would find out that Spring would not work. Transactional would not work once you have checked your exception and wrapping your application in a try and catch and expecting it to work. So it seems that you already know that there's going to be a problem here. So let's just allow you do what you want to do. Then I would just stay the way I want to stay. So the exception is actually swallowing the transaction annotation you get. So that is just what is happening at this point in time. So one of the ways you can do that is to remove your try and catch block. You can remove your try and catch block, and then you would be able to get your Spring transactional annotation running. So there's also something that can be done. You can also use a rollback for. That is when you are expecting the exception. There's a special way to also do that. You can use a rollback for and add the exception class. So if it is an input-output exception you're expecting to happen there, you just add that input-output exception class, and your transactional annotation would be able to function properly in that instance. And one of the key takeaways from this particular part is that use public methods with annotation, configure rollback for specific unchecked exceptions, that is if you're expecting one, and always rethrow exception or wrap an unchecked exception once to ensure rollback. So these are some of the key takeaways we should have for this particular part. And okay, so now some of the best practices to transactional management is to embrace declarative transactions. by the use of transactional annotation to manage transaction declaratively on our application. And one of the other things is to also understand the use of propagation so that we can know when to use either the required or the requires new for different complex application that we may be working with. Also, handle exception properly ensures that exceptions are properly propagated or explicitly configured for rollback to maintain data integrity. You understand? So with some of these, we can be able to um, um, handle or manage our transactions effectively. You understand? Also, another thing is to be aware of the proxies. Aware of proxy awareness would help us to also get this done, and read-only optimization. So these are some of the ways we can ensure that our transactional management work effectively for us. And overall, in everything I've said, from the beginning of the slide, or from the beginning of my presentation to this particular point in time, one of it is to embrace declarative transaction, which is what we mostly Spring Boot developers or Spring Boot users we do at this point in time. So that one is a check for us. Another thing is to understand propagation um, flows, how propagation are being used, or how to use propagation very well. Yes, like I've already said previously, is to also avoid some of the issues we would have or we should be having with proxy use. That is understanding AOP usage so that we would not fall into self-invocation. Also handle exceptions carefully, and yeah, so one last thing before I leave. Yes, I said I was going to talk about it, which is the aspect-oriented programming. So what it does is it's not very far-fetched from what we know as OOP. You understand? OOP is OOP like we know it, and Java it supports that. So AOP is used to support this particular concept. You understand? So they are not two different things. So it just supports it. It adds more context to it. It also helps us to, for some of the things that we don't know how they work, but they just work, like logging, like catching, and security, how security works, how transactional management also works. AOP is is the principle behind those processes. You understand? AOP is the principle behind it, how your caching system works, how your logging system works, how your security system works, how transactional management works. So AOP is the reason behind how those things work, because sometimes you just use them and then they do a lot of things under the hood, but AOP is the one responsible for it. Also, AOP is used in Spring Boot to provide declarative enterprise services, like I've already said. And then it also provides modularity in Spring framework, which is it separates independent sections. You understand? And then this is the end of my presentation. And if there's any question, I will be available to also help us or give more clarity to it. And I want to thank you all for staying up until this time. And I hope I was able to give more clarity to how we understood transactional management. Thank you very much, everyone. So if there's any question, I think we can, maybe Samuel should help us with them.
Okay, okay. Thank you very much, Mr. Sampson. Thank you very much. And the end formality, we really appreciate. Whew, that was a very powerful session, and that's a lot to take in. That's why we record this session, because at some point you get lost, but that's a very powerful. I didn't know this exists, but thank you very much. Um, so if there is any question, you can ask now. I'm sure there are questions. Okay, yeah. Anybody else? Anyone else? Okay. So, Mr. Ahmed, you can ask your question.
Good evening, everyone. Thank you for the
Yes.
session. It was really powerful and very, very great. Thank you. But I have a
Thank you very
question.
much.
What if
All
we
right.
have a scenario in which a method is annotated with at async to run on another thread? Like you have like in an e-commerce system to process order. So when processing the order, we have to send notification. So the send notification is on another method. So that is annotated with at async, and so we call the method in that process order, which is annotated with transactional. So and what I understand is that the one annotated with at async is going to run another thread. So is the transactional going to work for that also? The transactional annotation in the process order in case the process fails midway. Thank you.
Yes, yes, it's going to. So, more like using a cron job, right? Can you confirm that? Hello,
No,
using a cron job
like we are
and
sending,
allowing me to run it on another thread,
yes, like we are sending email
right?
notification while processing the
No,
order. Yes.
sorry to interject. I'm not. I don't think it's talking about a clone job.
Okay, please, can you rephrase your
It's
question,
still
please?
more like a method call or a function call, just annotated with your asynchronous annotation async.
Should I repeat
Well,
the question?
I think, okay, can I go on?
Yes, sir. Yes, sir. Thank you.
All right, so I think that would work. I think that would work. Allowing that particular process to run on another thread, yeah, that would work. The transactional annotation would work because the aspects, the AOP would have to be the one to create that particular process, and then you get a rollback for that if there's an event of an error.
Okay, sir. Thank you.
Is that clear? Like, okay, go on, please.
Okay, good evening. Sorry for the interjection. So what I'm just here to do actually is probably to elaborate what he was trying to ask. So because it just read my mind. You understand? I was also trying to how am I going to put this? I wouldn't say it's a question for me though. More of like your own perspective of this sort of integrity management. At the same time, every other person learns from it. So I mean, right from the top, this has been a good presentation. So thank you for taking us through all this. So I would say, let me put it this way: the line of thought is still not in order. But you understand that in Spring Boot, you understand everybody, like you said, we make use of declarative, the whole declarative transactional, this and that. You just annotating maybe a method call, a function call with a transaction at the same time, maybe level of declaration you want, and the sort, right? So, but at some point, we also know that transactional is to help us, or is to ensure that let's say a method, or let's say a method's operation actually completes one atomic unit. You understand the whole acid, right? So maybe either a commit or the same time a rollback. So, but along the way now, you have your method functioning the way it is supposed to, based on the hierarchy of whatever services is being called or whatever repository. Understand? So, but at some point in time, you need to do some sort of, you know, uh, maybe some sort of offloading some heavy work. Understand? So, and maybe an example. You understand?
Okay.
Maybe I call a a batch, maybe let's
Mm,
say, or let's say create user, a bulk create user, right? I'm creating
yes.
multiple users, maybe via uploading of Excel file or something. or you understand. So, and at some point in time, I'm trying to also look into calling maybe an event service, or doing doing like let's say sending out email. Yeah, you understand. So at the point of creation, you also send out email that, okay, yes, welcome on board, this and that sort of thing. So and you understand that, okay, yes, at some point in time, this gets bigger. Understand? Maybe you are trying to write like thousands of users, right? Or maybe really moving from one system to another sort of thing. So an example of, okay, trying to move off that heavy work is maybe running the event service or the message service sort of asynchronously, you understand, which is annotating
Yeah.
with the async, right?
Yes,
So,
sir.
and this is also called within that bulk creation now, you understand, method. So the
Okay.
function calling, the function creating the bulk users, right? So, and like I said earlier, the idea of the transactional is to complete one atomic ring. Like, okay, when you say when you click and you say create, you understand, everything has to like run just in one atomic unit without breaking, right? If anything breaks, it rolls back every other thing. So
Okay.
how would you say, or let's say what's the English now? How do you maintain? Yes, exactly. How do you maintain that transactional integrity? In that asynchronous, we say world. I don't know if you get
So yeah,
the question.
I think I got the question now. Also with what he said earlier on. So the truth is, it would not work. You understand? In that particular process, because the both async and transactional, they all run on the OAP proxy. You understand? So having those two there, it will not allow it will not allow it to work. So one of the things to do is to avoid putting async and transactional on the same method. You understand? So you can call a separate transactional method from within an async method. Do you get what I'm saying? Hello? Hello? Can you
Yeah,
hear me?
I'm with you. I'm sure
Yes.
I'm
Oh,
with you.
so annotating a method with both async and transactional will not work. That's like a no. And but if you'd call within an async method, if you'd call a transactional method, a method annotated with transactional inside that async method, so that would start on its own thread. So that will work. That in that instance, you can say the both of them will work. You understand? But I hope it's not a little bit confusing. Hello? I hope this is clear.
I'm sorry, sir, but I don't really get what you are trying to do. Pass on.
So, okay. So let me come back again. What I'm saying is that if you have a method, like you said, let's say create user, and in that create user method, that method is annotated with async, you understand? And at the same time, that same method create user is annotated with @transactional. I'm saying that in that instance, the transactional will not work because both the async process and the transactional process, they all rely on the proxy, like the AOP system, the AOP proxy to actually function. So the transactional will not work at that instance. But in an instance where the main method is annotated with async, and within that method, you're calling another method somewhere else that is annotated with a transactional. In that instance, it would work. The transactional will work perfectly. That's what I'm saying.
Okay,
Because
okay, sir. Thank you.
it's going to create another thread. Do you
Okay.
get?
Yes.
So you would have two different threads now running. The first thread, which is going to be the async process, and the next thread, which is going to be the method called inside the async method. So that's in that instance, you would find out that it would work. So we can still, I don't know if it's right to say that you can then have both transactional and async method working, but that is just how it can work perfectly. Please go on.
Yeah, I think I sort of like the thought process, but if you say it wouldn't work, I'm not sure that's totally right. I don't know. I stand corrected. You have an asynchronous method in a transactional method. I mean, once you fire that service, you understand? The transaction itself, it's TX. It goes ahead to do what it's supposed to do, and as well as the asynchronous that you mentioned now, they would both run on different thread. The transactional is what's it called, thread bounded.
Yes,
So once you fire, asynchronous goes ahead to do his own thing. Understand?
yes,
So I think
yes.
the disadvantage here is just that if there is anything wrong, I mean anything goes wrong while running that process, whatever the asynchronous is handling, you
You
can't
can
roll that
tell.
back.
Yes,
So that data will definitely persist, but every other thing can be rolled back.
yes. Every other thing inside the other method annotated with a transactional will be rolled back.
Yeah,
Yes.
exactly.
So that is the only instance where it can work, where I can say it can work. But any other method process, like the reverse of that, which is putting them together, will not.
Sorry again. I'm not sure. Did we talk about event listeners for transactional, this declarative transactional annotation?
No, I didn't talk about that.
Was there anywhere we mentioned this? Okay. Let's not make this big. Let's just continue. Thank you.
All right then. Thank you very much.
Okay, thank you very much for that clarity. Thank you very much for that clarity. I appreciate Ahmed and Mr. Israel for the question and contribution, and also Mr. Samson for the wonderful presentation. We really appreciate. I don't think we'll be taking any more questions because we have spent we have used up all the time. So okay, so we are closing now. So really want to appreciate each and every one of us for attending today's session. We really appreciate your presence, and we continue next week. And this month we'll be having a very big speaker that is going to come. That is going to speak to us the second Saturday of this month. So we should watch out for that with a very powerful topic. So let's just keep our minds ready and continue to implement, keep on debugging, and keep on building. Thank you very much. Thank you very much. Thank you very much. Have a wonderful night.
All right. Thank you very much once again. Thank you for having me. All right. Good night, everyone.
Good night, everyone.